So today we are going to be looking at the unit circle. The unit circle is extremely helpful in trigonometry. That table that you had back in 9.1 with example 3, where we would set up the trig ratio and then we would replace sine of 30 with a value of some sort, that comes from the unit circle. So if you have this memorized, which you are going to have memorized for Friday when your quiz is, then you are going to be set for that type of problems that are going to pop up on the test, because you'll have the unit circle memorized, even if you do not have the table. So we're going to look at the unit circle in 3 different ways. We're going to start with the easiest, which is going to be our degrees, because we should know that our circle should have 360 degrees. So if I were to think about the starting point as being here, right, then that means the first degree, which I will try to show you, is going to be right here, right? This is going to be my first spot, and then I'm going to go around the circle, right, all the way around until I end up here at 360. So I can fill those portions in. So this is going to be 0, and then that means this is going to be 360, okay? So halfway, right, our halfway mark, so let me show you where that is. Halfway from 0 to 360 is right here. So this would be 180. All right, and then we can look at the other stuff. Halfway of that, right, halfway between 0 and 180 is going to be this degree up here. Half of 180 is going to be 90. And so if the distance from 0 to the 90, right, this quarter of the circle is going to be 90 degrees, then I can technically add 90 again to get 180, and I can even add 90 one more time to get this degree, right? So this will be 180 plus 90, which is 270, okay? And I can do it again if I really wanted to, and that would get me my 360, right? 270 plus 90 gets me 360. So there's that. Then I can look at, all right, so if we go back to that original quadrant right here, if this is 0 and this is 90, half of that should get me to this particular line right here, which is going to be 45 degrees. All right, and again, I can add it again, right? 45 plus 45 is 90. Keep going. 45 plus 90 degrees is going to give me 135. All right, 135 plus 45 gets me to the 80, right? I keep adding 45 degrees to get to that center circle, which I'm making pink. 180 plus 45 gives me 225, all right? And then 225 plus 45 gets me to 270, and I do it one more time to get 315, okay? So I have found all those other pieces. Now let's go back here. We are still missing these other 2 pieces. And if we look at this, portion of the pie, if we look at this, we can sort of see that it's separated into 3 pieces, right? We have this piece here from here to here, and then we have this piece here from here to here, and then we have this piece here from here to here, right? So 1, 2, 3. And if the whole piece of this pie is 90 degrees, then technically off to the side I can be like, well, 90 divided by 3, that's going to give me 30 degrees. So from here to here is 30 degrees, all right? And then I can do it again, right? From the blue line to the next blue line, that's another 30 degrees. So 30 plus 30 is 60, and then 60 plus 30 is 90, and then I'm go into the second quadrant there, right? So 90 plus 30 is going to give me 120 and 150, and I keep going. Technically, 30 plus 150 gives me 180, right? And the 180 is already here, so I don't have to write that. But then I go into my next quadrant, right? These 2 lines, so I'm going to go ahead and highlight them. All right, so 180 plus 30, that's going to give me 210. And then I add 30 again to get to my next one, and that gives me 240. All right, I add 30 to 240, and I end up with 270, but that's already there. So then I can go into the next quadrant. I need these 2 lines. 270 plus 30 is going to give me 300, and then 300 plus 30 is 330. And again, if I add it one more time, I end up with 360. All right, so I have all of my degrees now. So you will have to know these 100% for the quiz. So now let's look at the other piece. Let's look at the radians, which we haven't really talked about very much, but I'll explain that in 1 second. Let me clear off all of these highlights. So we'll talk about radians a lot more later, but for right now, I want you guys to think about radians as, instead of degrees, it's length, like an arc length, right? So the arc length around a circle is in total 2 pi. So we're going to take that idea and we're going to apply what we just did with the degrees and divide it into different sections. So again, if I'm starting at that right-hand side where 0 degrees is, that would be 0 pi, right? It would just be 0. 0 times pi is just 0. And then all the way around, right, as I said before, is going to be 2 pi. Okay, so then if I go halfway, right, from 0 to 2 pi, if I go halfway, that's not going to be 2 pi, that's going to be 1 pi, because half of 2 is 1. So I'll put just pi here. All right, and then if I, again, look at the halfway mark, 0 to pi, the halfway mark is going to be half of pi, which is, I'll write it as a fraction. And I usually use that bar as my fraction bar. So it's going to be pi over 2. All right, and now it's going to be a lot of fractions. I'm sorry, but it is what it is. So if I wanted to find, right, actually, let me go back. If I wanted to find from here to here, right, from 0 to 90 degrees is half pi. Then that means from 90 to pi is another half of the pi, which equals 1. So it would be like 1 half pi, 2 halves pi, which reduces and gives me 1 pi, all right? So I can apply that concept over and over and get my other pieces. So this is 1 half pi, 2 half pi, which reduced, and this is 3 halves pi, and I can go ahead and fill that in, 3 halves, or 3 pi over 2, is usually how I write it. And then finally, I end up with 4 halves pi, which is, again, 4 divided by 2 is 2 pi. Okay, so then I keep going, right? I have 0 to half, or pi over 2. Half of that is going to be a fourth. So 0 to 1/4 pi. So I'll write it as pi over 4. And so I can apply this concept. Each quarter, right, is going to be a fourth of a pi. So 1/4, 2/4, which reduces to 1/2. The next one would be 3/4, right? So 3/4 pi. This will give me 4/4, and 4 over 4 reduces to 1 pi, so that one's good. I keep going. This next one will be 5/4, so I'll fill that in, 5/4 pi. The next one will be 6/4. 6/4 reduces to 3 over 2, and then that means the next one will be 7/4, 7/4 pi. Okay, and then again, if I wanted to keep going, that would be 8/4, which reduces to 2. Okay, so I'm just taking those concepts and I'm just making them fractions now, okay? Then we look at the final piece, which is this radian right here. As I said before, we are, this quarter, this portion of our unit circle is reduced with these out, or not reduced, but broken up into 3 parts. So I'll do a little bit of math off to the side. I'll say pi over 2, that's the arc length of that entire portion, right? From here to here, the arc length is pi over 2. I'm going to divide that by 3 because it's in 3 pieces. Remember, you can't really divide a fraction by another fraction, so we're going to do keep, change, flip, right? Keep, change it to multiplication, and I'll flip 3 to become 1 over 3. And now it just is multiplied across, right? Pi times 1 is just pi, 2 times 3 is 6. So if I am just looking at one portion of this, that was, cut into 3 pieces, right? Then one portion is pi over 6. So I'll go ahead and I'll put that, pi over 6. That means the next piece, right? The next piece over is 2 pi over 6. But 2 pi over 6 can actually be reduced to 1 pi over 3, 1/3, right? So I'll instead of putting 2 pi over 6, I want the reduced fraction. Okay, so again, each of these outer lines, if you will, are going by 6. So 1/6, 2/6, 3/6, but it's already here reduced, so we ignore that. 4/6, so 4/6 can be reduced. 4 pi over 6, those are both divisible by 2, and I get 2 pi over 3. Okay, so now I'm going to fill that in for this piece. 2 pi over 3. Okay, so that was 4/6, which we reduced. That means the next one is 5/6. Okay, and then we keep going, 6/6, which is going to reduce to 1 pi. The next one would be 7 pi over 6, which I cannot reduce, so I'll just bring that over. The next one will be 8 pi over 6, so I can reduce that one. Again, divisible by 2, so that'll give me 4 pi over 3. So that'll be 4 pi over 3. Let me fill that in. So that was 8, right? 8 pi over 6. This will be 9 pi over 6, which is already reduced. The next one is, 10 pi over 6. So 10 pi over 6, again, we could reduce that. It'll become 5 pi over 3. So I'll fill that in, 5 pi over 3. 3 is a little hard to read, but anyway. So this was 10, and if we go one more time, that'll be 11 pi over 6. Okay, so I have taken the arc length of my circle, which was 2 pi, and I have broken it up into all the pieces, and so these are our radians. And again, we'll talk more about the radians later, but for right now, I just need you to know that these are the values. At these positions, the radian is going to equal this, okay? All right, so then the final piece is our ordered pair. So let me clear off the math off to the side, and then we will do that. Okay, so now we're going to talk about why this is called the unit circle in the first place. So the unit circle is called this because it's with the assumption that this circle is placed on a coordinate plane. So let's go ahead and add our x and y axis here. It's a little scribbly, but you'll be fine. And if this was my unit circle and I had only one unit as its radius, well then that means that my ordered pair over on the right-hand side here, right? This would be the ordered pair 1, 0. And that means that if my radius again, right, up here at the top, this would be, instead of going on the x-axis, now on the y-axis, this would be 0, 1. And then if I, from the origin, right, go to the left, well, this would be -1, 0. And then if I go below the origin, this would be 0, -1. So the question is, how do I get all of the stuff over here? Well, I'm going to explain that to you. It's not necessary that you know how and why, but I do want you to just have a basic understanding. It's based off of the special triangles we learned back in 9-1. So if I were to look at the first triangle, and I'll highlight it in red for you. So here's our radius, right? The radius is 1. If I drop down, right, drop down a line and make a right angle here, then this is going to be my x value, this is going to be my y value, which I need for the ordered pair, right? You need x and y to create the ordered pair. The place near the center here is going to be my theta, right? Theta is going to be equal to 30 degrees, okay? So if that's the case, and remember there's 2 methods that I taught you. One of the methods was to just create your trig ratio. So let's say I wanted to use my hypotenuse and find the opposite. Well, that's the sine trig function. And I'm looking for sine of 30 is equal to opposite over hypotenuse. Okay? And then I can multiply by 1 on both sides, which is just going to give me sine over 30 is equal to y. And I can type in sine 30 into my calculator. Go ahead and do it. See what you get. If you did it correctly, you should get 0.5, which is the same thing as 1/2. So I can fill in my y value, because remember, we're solving for y. It's an ordered pair. Y is going to be 1/2. I could have done the exact same thing with the other method, which was using the blueprint from a 30, 60, 90 triangle. Remember, across from the 30 degree, that is going to be my x length. Across from the 90 is double that, and then the 60 is going to be x times the square root of 3, okay? If they gave me my hypotenuse, which is 1, I can find 30 by halving it. So half of 1 is 1/2. And then I can take that leg length across from the 30 degrees, and I can multiply it by the square root of 3. And so that means, right, if I clean this up a little bit and make it one fraction, I can fill in my x value as the square root of 3 over 2. Now, the cool thing about the unit circle is that there's a lot of patterns inside of it. So if I create the triangle, right, on the left-hand side, then I can have the exact same ordered pair as what I have over here. The only difference is on this side, the x values are negative. So I'm going to make it negative square root of 3 over 2, comma, 1/2. And I can do the same thing in the quadrant below. This is the exact same position on the unit circle, right? It's the same position. And this time it's going to be both the x and the y values are negative. So this will be negative square root of 3 over 2, comma, negative 1/2. And then I can do the same thing in our fourth quadrant, right? Here is the same position, the same triangle, and it's going to be x values are positive now, but the y values are negative. So it's going to be the square root of 3 over 2, comma, negative 1/2. So in these, you can think about it like a bow tie. I think I've heard that term before. If you create the bow tie, these order pairs should be exactly the same. The only difference are the signs. Okay, so let's look. I won't do all the triangles like this, but I am just going to tell you what that first quadrant is, but let me clean this up first. So as I said before, I'm not going to show you the math behind everything, but I am just going to tell you what the next one is. So the 45-degree ordered pair is going to be the easiest one to remember because they're the same number. It's going to be the square root of 2 over 2, comma, the square root of 2 over 2. All right, so if we think about that like bow tie shape that I mentioned before, right, it's this center line here. And so if I know that this center line is going to be the square root of 2 over 2 and the square root of 2 over 2, then that means the other center line is going to be the square root of 2, comma, the square root of 2 over 2. The only thing is, what are the signs? Well, it's going to follow the same pattern as before. If you think about it as the quadrants, this quadrant right here, and I'll even write it, I recommend you do the same thing. But if I write it out, then the order pairs in this first quadrant are going to be positive, positive, right? Everything on this, the x is positive, the y is positive. If I go to quadrant 2, right, that's going to be this quadrant over here, the x value is negative and the y value is positive, okay? And then I go down to quadrant 3, and that's going to be both values are negative, x and y. And then quadrant 4 is going to be when the x value is positive and the y value is negative. So now that I sort of have this basis, this sort of notes, it's a lot easier for me to just put my numbers and then add my signs. So if I create that bow tie, let me highlight it for us. The bow tie in quadrant 2, right, it's that center line. It's going to be negative. All right, I'll fill the rest of mine. Hold on. All right, so here's the whole bow tie, and then we keep going. The negative square root of 2, right? Make it negative, comma, positive square root of 2 over 2. And then the next one, they're both negative. So negative square root of 2 over 2, negative square root of 2 over 2. And then I go to quadrant 4. The first one's positive, positive square root of 2 over 2, then negative square root of 2 over 2. Okay? The final one is the same 30, 60, 90 triangle, but it's flipped. So if the 30, 60, 90 triangle is flipped, then that means the order pair is also, not flipped, but switched, if you will. So instead of it being like what we have over here, where the negative, the square root of 3 goes first, I'm actually going to put the 1/2 first instead. So this is going to be the order pair 1/2, comma, the square root of 3 over 2. And the reason that happens is because basically it's the same shape, right? It's a 30, 60, 90 triangle no matter what, but theta just moves. Instead of it being in the corner of the 30 degree, now it's in the corner of the 60 degree. So it makes sense that the values are equivalent, but from its perspective, the x and y just switch. They switch places. So I can continue that idea with the next one. I'm not going to draw my bow tie this time, but I have the negative 1/2 square root of 3 over 2, right, in quadrant 2. And then I come over to quadrant 3, my last one. That's going to be negative 1/2, comma, negative square root of 3 over 2. And then I do it again. This time my x value is positive, so 1/2, comma, negative square root of 3 over 2. All right, so now I have completely filled in my unit circle. So what is the purpose? But why? Well, your worksheet, your homework, is actually why we do this. So I think that's everything that I filled in here. Okay, great. So the last thing I want to write on here is that depending on your ordered pair, right? Remember that an ordered pair is x, y, right? Well, x is going to be our cosine value, and y is going to be our sine value. And I'll show you how that's helpful once you get your worksheet. So let's look at that really fast. Okay, so here is your worksheet. And on the right-hand side, I have the unit circle, because you should be looking at these the entire time, both of them at the same time, because I'm sure you don't have the unit circle memorized already. So the nice thing about the unit circle is it tells us exact values quickly, and that's the whole purpose of it. So this worksheet is just to help you go through the process of pulling the exact values immediately. The exact values can be found with the ordered pair. So let's make sure we remember. Let me write it down. I have an XY ordered pair normally, right? And so the XY ordered pair, because we're talking about trigonometry, has now changed to cosine and then sine. So the x value would be cosine and the y value would be sine. So I'm going to be using these ordered pairs off to the right. And if they're asking for the cosine, I need to look at the x value, right? These x values. If they're asking for sine, then I need to be looking at the sine values. So that's how we're going to use this. So let's go ahead and do that first one. We have cosine of 30. So let's find 30 degrees, right? 30 degrees is right here. And so now I'm looking at my ordered pair. The cosine is my x value. So I'm going to just put cosine and sine, right, just to help me remember. So that value of the cosine is going to be my answer. So I'm just going to write the square root of 3 over 2. And that's my answer. So notice up here it says find the exact values, no decimal approximation. So please do not plug this into the calculator. If you do that, you won't get any credit, and you'll get a very bad grade. So don't do that. So let's do the next one. Number 2, sine of 45. So let's clear that off. 45 degrees is here, right? Again, I'm looking at my ordered pair. This is my cosine information. This is my sine. So if that is the case, excuse me, then my sine value is going to be the square root of 2 over 2. All right, so I'm just pulling that information, all right? And it doesn't matter where we are on the unit circle. So number 3 is 240. Well, 240 is in quadrant 3, all right? And sine, again, is the y value, cosine and sine, right? You can think about it, if you're like confused about the order, think about it, it goes in numerical order. So C is first in the alphabet, and then S is later in the alphabet, so that goes second. So this is going to be the value negative square root of 3 over 2. All right, so if we look at number 4, this is where things get a little bit different. We have cosecant of 60 degrees. So let's pause. Let's talk about cosecant. Remember, there are the original 3 trig functions that you guys know, right? We have our sine, cosine, and our tangent. And I said you have reciprocals of these. And those reciprocals are going to be, the reciprocal of tangent is cotangent, right? Because every relationship has to have a co in a relationship. So that means that for cosine, I'm left with cosecant or secant, and I already have used the co. So it has to be secant. You can shorten that up with SEC. And then sine will be cosecant. Okay, so in this particular case, cosecant number 4, cosecant of 60, I need to take my sine value, right? So here is 60 degrees. My sine, these are reciprocals. I'm going to write that down. Reciprocals. There we go. So here's my ordered pair. I'm taking my sine value, the square root of 3 over 2, and I'm going to flip it. So now it's going to say 2 over the square root of 3, right? And then from here, if it was just a nice, happy number, I would just box that in. That would be my answer. But unfortunately, in this particular case, that is not what's happening, because I have a radical in the denominator, and I'm not allowed to have that. So I have to rationalize. So I'm going to multiply top and bottom by that square root of 3. All right? In the numerator, it's going to say 2 times the square root of 3 over 3. and this is my answer of cosecant of 60. So if it's sine or cosine, very straightforward. If it's cosecant, you take it and then you flip it. So let's try a couple others just to make sure we've got it. Let's try a tangent really fast. Let's see. So if we look at number 11, it says tangent of 90 degrees. Well, we've talked about the ordered pair having cosine and sine, so where does tangent come from, right? So here's the 90 degrees. I'm going to give you a property, and you should definitely write it down on your unit circle. And the property is that tangent is equivalent to opposite over adjacent, right? We know that one. But it is also equivalent to sine divided by cosine. Sine divided by cosine. And we could even, if we wanted to put our variables here, it would be y over x. Okay, so I'm going to use both of my the numbers in my ordered pairs to find the tangents. So I'm going to say, all right, here's my cosine, here's my sine. All right, so on my paper, I'm going to write it one more time. Tangent is equivalent to sine over cosine, right? And then I fill in my values. My sine is 1, and my cosine is 0. And if I type this in the calculator, which you should definitely try on your own, it does not equal 0. It actually equals nothing. It's an error. It's undefined. So I'm going to go ahead and say this is undefined, and I'll box in my answer. So obviously that's not always going to happen. So what would it be if they were like actual numbers? So let's try number 12. This is tangent of 315, right? So let me get rid of that. 315 is right here in quadrant 4, and I'm going to do sine over cosine. So here's my cosine, here's my sine. It's going to be that negative square root of 2 over 2 divided by the square root of 2 over 2. Now, if you remember your properties of division, anything divided by itself is, well, 1. So this is going to equal, it's going to be a negative 1 because we have a negative, right? But this is my answer. So if it was not, if you forgot that property, then you could always do it the long way, which is, okay, you write it out, negative square root of 2 over 2 divided by the square root of 2 over 2. And then you can't divide by your fractions, so it's keep, change, and then flip, right? And then from here you can reduce. I got 2 2's that I can cancel out. I got that square root of 2 I can cancel out, and I'm left with a negative 1. So you could do it the long way if you wanted to. It doesn't really matter. So now that we have that sort of under our belt, let's go to the back side, which is literally the same thing, but it's just presenting, instead of degrees, it's presenting the radians, but it's the exact same idea. Okay, so here is the other side, and again, it's asking the same exact types of questions, but they're just presented as the radians. So it's the same thing as before, and so let's do number 16, cosine of 2 pi over 3. Well, 2 pi over 3 is going to be over here in quadrant 2. Remember, our x value is cosine, our y value is sine, and so our cosine information is what we need, the x value is what we need, and so therefore our answer is negative 1/2. All right, let's do one more secant and cosecant one, since that involves our reciprocals. Let's do number 20. That is secant of 4 pi over 3. So 4 pi over 3 is in quadrant 3. And let me write these relationships one more time. I've got secant is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is cotangent. All right, so I want to have the secant, which is the cosine reciprocal. So here's my cosine, here's my sine. I need to take that negative 1/2. I need to flip it, and it'll become negative 2 over 1, technically. And we can reduce that and just say negative 2 as our answer. All right, so that is it. Please make sure that this worksheet is completed by tomorrow. All right, have a great day.